Welcome to The Explainer. Today, we're diving into something that's, well, it's pretty much everywhere, but you can't really see it. We're talking about distributed systems. Seriously, from the cloud that holds all your photos to the smart speaker on your counter, this is the computer science magic that makes our connected world actually connect.
So, what is a distributed system, really? At its heart, it's pretty simple. It's just a bunch of separate computers that work together so well that to you and me, they look like one single, super powerful machine. They're a team, basically, tackling jobs they could never handle on their own.
Okay, so to make sense of all this, computer scientists have kind of sorted them into three big families. Each one has a totally different job. You've got the heavy lifters for massive calculations, the super organized ones for managing data, and then the sneaky ones that just disappear into the world around us.
All right, here's the plan. We're going to tackle the powerhouses, then the organizers, and finally the invisible fabric. And then we'll wrap it all up with the big picture.
First up, let's talk about the powerhouses, the computing systems. These things are built for one reason and one reason only: raw, hardcore computation. We're talking about the kind of muscle you need to crunch numbers for scientific breakthroughs, or to render those jaw-dropping special effects in the latest superhero movie.
Now, inside this family, there are two main flavors. You've got cluster computing. Think of it like a team of identical twins working on a puzzle. They're all the same, they're sitting right next to each other, and they're super coordinated. Then you have grid computing. This is more like recruiting a team of experts from all over the world. They're all different, spread out, but they come together to form this one virtual supercomputer.
And here's what that cluster looks like under the hood. You see that master node? That's the boss. It's the brain of the operation, handing out jobs to all the identical compute nodes. It's this tight, top-down control that makes clusters so incredibly fast and powerful for specific tasks. A grid, on the other hand, is a whole different beast. Because it's pulling together all sorts of different computers from different places, it needs to be way more organized. And this diagram shows that perfectly. It's built in layers. You start with the fabric, that's just the actual hardware, and you build up from there, adding layers for connectivity and resources until you get to the apps that people actually use at the very top. So all this talk about grids leads us straight to something you've definitely heard of: cloud computing. The cloud is basically the next step, the commercial evolution of grid computing. It took that awesome idea of a virtual supercomputer and turned it into a product. Now you or I can just rent a piece of that power, on demand, and only pay for exactly what we need. It's a game changer. But here's the thing you've got to remember. The cloud isn't just one thing. It's more like a menu with different levels of service. At the bottom, you have infrastructure as a service, IaaS, where you're basically renting the raw building blocks, like servers and storage. A step up is platform as a service, or PaaS, which gives you a workshop to build your own applications. And at the very top, you have software as a service, SaaS, which are the finished products you use every day. You know, like Google Apps.
All right, let's switch gears. We've talked about the muscle. Now let's talk about the brains. We're moving on to our second family, information systems. These aren't about raw number crunching. Nope, these are the systems that organize, manage, and process data. They are, and I'm not exaggerating, the workhorses of the entire global economy.
That's right. Think of these as the global nervous system for business. Every time you use your credit card, track a package, or transfer money between accounts, you're using one of these systems. Their number one job? To make sure that every single transaction is handled perfectly with total reliability.
And to make sure everything is rock-solid reliable, these systems rely on something called transactions. And every single transaction has to pass the famous acid test. A is for atomic, it's all or nothing. C is for consistent, it can't break the rules. I is for isolated, one transaction can't interfere with another. And D is for durable. Once it's done, it's permanent, no takebacks.
So how on earth do they manage all that, especially when a single action might involve multiple databases? Well, meet the hero of the story, the Transaction Processing Monitor, or TP Monitor. It's literally a traffic cop for data. Imagine you're booking a flight and a hotel at the same time. The TP Monitor makes sure that both bookings go through. If the hotel booking fails for some reason, it automatically cancels the flight booking too. It's the thing that guarantees that all or nothing rule.
Okay, for our last category, we're going where the computer disappears. I mean, it literally just blends into the background, becoming part of the world around us. We're talking about pervasive systems, sometimes called ubiquitous computing.
So what makes a system pervasive? Well, a few things. First, the computers, or nodes, are tiny, often mobile and stuck inside everyday objects. The whole point is that the system just fades into your environment. And these devices are always ready to connect, anytime, anywhere. We're talking about everything from your smartphone to your smartwatch to massive networks of tiny little sensors.
And this is where it gets really personal. This is the tech that powers your smart home. You know, when your lights, thermostat, and locks all communicate. But it's also the tech that's revolutionizing healthcare. Think about a network of tiny sensors on a person's body, a body area network that constantly monitors their health. This isn't science fiction. This is technology that can and does save lives.
And even here, there are different ways to build things. You can go the dumb route, where a bunch of sensors just collect raw data and send it all back to a central server to be processed. That's on the left. Or you can go the smart route. That's on the right. Here, each sensor is intelligent. It can process data itself, talk to its neighbors, and only send back the final, important answers. Way more efficient.
All right, we've covered a lot of ground, from massive supercomputers to tiny sensors. So let's pull back. What's the big takeaway from all of this?
It really comes down to those three big families. You've got the computing systems, the superbrains we build to solve huge problems. Then you have the information systems, the super reliable nervous system that runs all of modern business. And finally, the pervasive systems, the ones that are literally weaving technology into the world we live in.
And that leaves us with one last, pretty big thought. These systems aren't just a topic in a university course anymore. They are the foundation of our world. The line between the digital and the physical is blurring every single day. So the question isn't if our world will be a giant distributed system. It already is. The real question is, how are we going to choose to build it and manage it?